In the last class, we discussed about those detailed syllabus, okay, and we discussed about the learning objectives of this subject and the field application, okay, after studying this subject, means field application of this subject that we discussed in the last class. So today we'll start the first chapter, that is groundwater hydrology. So in this chapter, we'll discuss about the importance of groundwater, available water on Earth, hydrologic cycle, types of aquifer, storage coefficients, groundwater basins, Darcy's law, and permeability. Okay, these things we'll discuss in the first chapter, this groundwater hydrology. So first, we should know about what is this groundwater. We should know the concept of this groundwater, how it formed. Okay, this groundwater is also called subsurface water, and it is present in subsurface environment of Earth. Okay, and it is important component of the whole water source system. And why it is important? That I am to tell that because it is the largest reservoir of fresh water. Okay, that is readily available to humans. Readily available means it don't need any treatment. Okay, nowadays the filters are available for different companies, GWAD or different companies are up there to they're producing this manufacturing these filters. Okay, actually this filter are used for the river water. Earlier there is no filter system, nothing. Only the people use the groundwater, well water, the tube well water. So they construct the tube well in their backward and they draw the water. And the fresh water, without treatment, directly we can drink that water. But the river water, we cannot drink directly because it is more polluted. Obviously, the of course, this groundwater nowadays is polluted to some extent. Some area, in some area, not in all areas, we cannot say. In some areas, like in West Bengal, a high arsenic content is there. So some areas we cannot drink, but overall, if you compare with the this river water, the groundwater can be directly can be taken. Okay, and this river water is highly polluted, and river water cannot is not available to normal people. Okay, like from this river, you cannot say apply the water to every households. Okay, for that canals required, for that network is required, pipe required. So it is a big project. Okay, usually in village people that is not available. Okay, in the city or town it is available. So the village people, what they do, they use this groundwater. Even some town and city, they also use groundwater because it is readily available and without treatment they can drink directly. That's why this groundwater is most important. And 90% of the earth's fresh water is groundwater. Some fresh water is available in lakes, streams, okay. But the 90% of earth's fresh water, I'm telling about only fresh water, the 90% is groundwater. And here, this is the land surface water, this river water is surface water. And when there will be rainfall, the rainfall water passes through this soil layer and the rainfall water passes through the soil layer. Okay, and this soil layer, the water, they can join to this water table. So here, this soil layer is unsaturated zone or you can say the partially saturated zone. Means here there will be moisture, okay, soil moisture, but you cannot take that soil moisture for the drinking. You cannot withdraw that water. That is available for the plants. Okay, through the capillary action, the plants can withdraw this water, this soil moisture water, and they use for their this for their growth. Okay, And this water which joins to the ground water table, it is fully saturated. This water, this layer is fully saturated. That is called saturated zone. Okay, so here there is no air. Here all the voids is filled with this water, and the soil particle or the rock particle will be there. But here in the unsaturated zone, there will be air, there will be some water, there will be soil. Okay, some voids will be there. So groundwater fills the spaces between soil particle and the fractured rock beneath the earth surface. Okay, so the space, okay, is filled up by this water in the ground. This groundwater can be extracted from aquifers through pumping wells and supplied for domestic use, industry, and agriculture. You can see here how the groundwater formation occurs. When rainfall occurs, the rainfall water directly, first year directly through the soil layer, directly passes to this water table. This is called recharge precipitation. Recharge precipitation means precipitation water directly enter to the groundwater. So here recharge and discharge. Recharge means how the water join to the groundwater. Okay, means the water is contributed to the ground. That is called recharge. Discharge means the water which is flowing in the stream. Okay, so this is the precipitation recharge. The stream, some stream also contribute water to the groundwater table. Some stream there will flow in this direction. Okay, from the stream to the water table, and there is some stream which is means the groundwater is contributed, which is contributed by the groundwater. This stream is called effluent stream. In effluent stream, it means the water is moving away from ground table towards the stream. And if water is moving from the stream and it is contributing to the ground water table, then it is called influent stream. This stream is called influent stream. Okay. So with respect to the groundwater, the naming is given. With respect to the groundwater, naming is given. If it is towards the groundwater, it is called influent. If it is away from groundwater, it is called effluent. Okay, effluent stream. So this is called recharge ditch or recharge canal or recharge stream, or influent stream. And this is the zoom portion. This is the zoom portion, okay, of this layer, this unsaturated zone, this soil moisture. There will be soil moisture here. Okay, I mean this water is used for the plantation, is used by the plantation, and this is the zoom portion of this unsaturated zone. You can see here air, some water, okay, some water, and the soils, major portion is soil. But here this portion is zoomed here, okay, to show the water content. Here major portion is water, and there will be soil or rock or the gravel. Okay, so there is no air. Okay, and this layer, this groundwater layer, it is called saturated zone, and the flow, the direction depends upon the elevation, depends upon the, because the water moves through the gravity, but the gravity it moves. So depends upon the elevation, and depends upon the this geological feature of this earth. Okay, the direction will be like that. In shear, let the sea is in this side. Usually the flow occurs from this land to sea, towards the sea. Groundwater discharge to the sea. Okay, and seawater also, some seawater also flows towards the groundwater. If it flows, then there will be in this portion you will find the that is called saltwater intrusion. Okay, some saltwater enter to the groundwater. There will be mix. Okay, so usually in the coastal area, you will find the groundwater, salty groundwater. You will find salty groundwater, and some salt content will be there. With the increased withdrawal of groundwater, the quality of groundwater has been continuously deteriorating. Okay, so by increasing withdrawal of groundwater, okay, the level of groundwater decreases. That is called a depletion, groundwater depletion. Okay, and if groundwater depletion will occur, then the pollutant concentration increases, because pollutant concentration means the mass of pollutants per unit, this volume of water, the concentration increases. So it will be gradually the water, which if less water, then there will be more pollution. And the pollution, for the main reason for the pollution is the water, how it is supplied to the ground. Like here, for an example, here in the soil, when rainfall water passes through the soil, then it reaches to the groundwater table. If this is a agricultural land, then there will be fertilizer. The soil must be mixed with this fertilizer. So when water passes through this soil, so it takes some fertilizer with this water. The water takes some fertilizer, and that causes pollution. And that water joins to the this water table, and that causes pollution. That is the major reason for the pollution. First is agriculture, second is industry. Industry, they discharge water, dirty water, to this polluted water to this stream, and that stream water joins to this groundwater table, and that causes pollution. Okay, so these are the major reason for the pollution: industry and agriculture. These two are main culprit for the pollution. If you compare the Punjab, Haryana, that side, they use high fertilizer in their field. Okay, and due to this green revolution, they mostly depends upon the agriculture, and this due to the this economical crops, due to the economical crops, you can say, they use high fertilizer. So the groundwater is highly polluted. Okay, there. So this is about the formation of groundwater, how the pollution occurs, how the groundwater moves, the direction, and about influent and effluent stream. Next is the flow of groundwater. Okay, we know that ridge line that we know in the surface water, if there is a basin, two basin, okay, and the basin is separated by a line. If there is one basin here, one stream is here, another stream is here. Okay, this line which divides the two basins is called ridge line. Means when rainfall occur here in these areas, then the water will flow to this stream, towards this direction. Okay, when rainfall occur in this basin, the water will flow in this direction. Means it moves to this stream. So this line divides the two basins. That is called ridge line. So similarly, here in the groundwater, there will be a line which is called groundwater divide. This line, it divides the groundwater. Means if rainfall occur, if groundwater moves will be there, water will move in here, then that will be move in this direction. If there will be flow of groundwater, that will move in this direction. So here, in this direction, the flow may be towards the stream, or it may be out from stream, but the direction will be like this. Here there will be water direction to, if let this is the seaside, then there will be movement towards the seaside. Okay, so when rainfall occur, if you see the rainfall occur in this part, in this area, then movement will be in this direction. If there will rainfall occur in this direction, then movement will be in this direction. Okay, so here there is one stream, here there is lake. So if there is lake, then towards the lake there will be movement. But if there is stream, it depends upon the elevation of the stream. Okay, always it will not be towards stream, or it will not be from the stream. So it depends upon the elevation where this is groundwater table and the stream. Okay, stream bottom level and this is groundwater table top level. If it's here in this situation, in this as shown in this figure, it will be towards the stream. If the groundwater table is somewhere here, if this is the groundwater table, then there will not be movement towards the stream. Even the stream water will also come to the this groundwater table. So when there is pumping, this is the figure without pumping. This is the means figure with pumping. If there is pumping, then the water table reduces. Like here it is here it will be reduces. This is called cone of penetration. This cone shape is called cone of penetration. And here you can see the movement is towards the sea, but here the movement will be towards this well because we are withdrawing the water. So here the movement will be towards this well, this pumping well. Okay, so this is the how direction means changes when there will be pumping, and how the direction changes when there will be sea or there will be stream, and depends upon the elevation. Okay. Next is importance of groundwater. Why groundwater is important? If you consider 3% of our water is fresh and potable, total water available in the world, okay, the earth, the ocean water is 97%, or the salt water you can say. Ocean water which you cannot use for drinking. Only 3% is the fresh water. Okay, and then that fresh water is not easily available. In some fresh water, out of this 3%, 85% means out of this 3%, 85% of this 3% is in glacier form. Okay, out of this 3%, 85% is glacier form, 15% is groundwater and other fresh water. Okay, groundwater is 14 and 1% is other fresh water like streams, small streams, lakes. Okay, so 14% is fresh water and available in the groundwater out of this 3%. So if you neglect this glacier, if you not consider the glacier, if you neglect this, means out of this this 15%, if you consider, the 94% is available as groundwater. 6% only other fresh water like lakes or streams. Okay. So this figure should not be confused about, because here this 85% is out of this 3%. 85% of 3% or 15% of this 3%. This is the 94% of the 15%. If you neglect this glacier, because that will not be available, so you neglect that glacier. So out of this 15% of this 3%, okay, the 94% will be ground and 6% will be lakes, and like this calculation is done. In the calculation here, the glacier is not considered. So all the groundwater is only 0.6% of the earth water. It is 14% of the fresh water. Here as shown here, 14% of the fresh water. 0.6 of the earth's water means overall water. If you consider all water, including this salty ocean water, all water, whatever available in the world, okay, out of this 3%, 0.6% of this water is fresh water available as in ground. Okay. So excluding glaciers, groundwater is 94% of the available fresh water. And the drinking water for drinking water purpose, more than 50% of the population depends. Okay, it accounts for 40% of the irrigation water, provides 25% of the industry industrial needs. Okay, so more than 50% of people uses groundwater for drinking. 40% of the irrigation water is contributed by this groundwater. 25% of the industrial needs is contributed by this groundwater. Therefore, this groundwater is most important. If you compare the surface water and the subsurface or this groundwater, okay, here you can be clear about this, why this groundwater is most important. First, for a surface reservoir, you need more space. So for that, space required. Here, large capacity, if space is there, for groundwater, you don't need a separate space. High evaporation loss, in case of this lakes or this rivers, means the surface reservoirs, okay, there is practically no evaporation loss. So this surface reservoir need large area of land, but here very small area of land is sufficient. May fail catastrophically. May fail catastrophe means if you construct a dam to store the water, means to construct a reservoir. So if that dam fails, then there will be catastrophic damage to the downstream portion, downstream of this reservoir. In the case of groundwater, there is no danger of failure. Varying with water temperature. The surface reservoir varying with water temperature. Water temperature is uniform here in surface reservoirs. It is easily polluted. You know that river water is easily polluted. Okay, and here the subsurface reservoirs, groundwater, usually high biological purity. All the pollution can occur. Okay. Like I told, pollution occur in the groundwater, but comparatively very less. If you compare with the river water, it is very less. Okay. River water easily contaminated by radioactive fallout. Okay, it is not rapidly contaminated by radioactive fallout. Water must be conveyed. Okay, water must be supplied to the households. But here, the groundwater automatic. If you just construct a well or a tube well, automatically the water will rise. Okay, act as conveyance system. That groundwater itself act as conveyance system, thus obviating the need of pipes or canals. Okay, but well, if you are going to construct, then automatically the water will come, and there it's not this piping system. Everything is not required. Okay, for a tube well, you need small pipe because okay, so through pressure you have to take water. So compared to this river water conveyance, pipe or these canals or these things is not required. This is the availability of groundwater. Okay, globally, if you see, okay, globally, if you see, as I told, that 97%, nearly 97%, okay, as for this 87 Raghunath report, it is 97.2. Okay, whatever this, nearly 97% is salt water or the ocean water, and nearly 3%, or you can say 2.8%, as mentioned by this Raghunath. Okay, because time to time this changes. Okay, there will be change in the 87 report that. This report is the maybe latest report. Okay, this is the latest report. Actually, this is a CWC report. This 2.8% is fresh water. Out of this fresh water, this 2.8%, surface water is 2.2%, glaciers 2.15%, lakes and reservoirs 0.01%, streams 0.0001%, atmospheric water is 0.001%. And groundwater is 0.6%. Groundwater is 0.6%. Okay. So here it is mentioned 0.6% means, like here it is mentioned 0.6% means of all water that is available in the world. Okay, including glacier, including ocean, everything. If you compare, if you take all water, then total 0.6%. Okay, of fresh water is available in groundwater. 0.6% is available in groundwater, which is fresh, and economically available 0.3%. Economically available 0.3%. Another 0.3% you cannot draw. It means the depth of water is available. So depth of this groundwater table is very high. You cannot draw that water, like in hilly side. Okay, that we cannot draw. And in the plain areas, the water table is very near, so easily you can withdraw that water. That's why it's saying that economically available water, which is 0.3%. So you should not be confused about this values, okay, about these values, okay. Next is availability of groundwater in this map globally. If you see here, the aquifer system, the major which is easily available aquifer system, regional aquifer system, major regional aquifer system is shown by this line, okay. Here you can see these portions in India is major aquifer system is there, regional aquifer system means easily you can draw. Here you can draw these portions, you can see. An area with some important but complex aquifers. Complex aquifer means the complex aquifer system means it will be mix of the small aquifer system, okay, small groundwater portion, or maybe it's divided with rocks, okay. So complex means it's difficult to withdraw the water easily, okay. And here in areas of generally low permeability with local minor aquifers means the water is not available for the use. These white portions, okay, these white portions water is not available. Groundwater is not available. Especially if you see India, most of the area it is available. Water is available, easily available, and so most of the area it is available, but aquifer system is little complex. As far as this India is concerned, the annual replenishable groundwater resource is 431 billion cubic meter. Means total groundwater is 431 billion cubic meter. Out of this 431, 396 billion cubic meter present in the groundwater, and 35 billion cubic meter that contribute to the stream. Okay, as I told, some water contribute to the stream. If you see in the summer season, like in Ganga River, Brahmaputra, here Mahanadi, Baitarani, Brahmani, all the major rivers in the India, you'll find minimum water, some minimum base flow, that's called base flow, some minimum water you will find in the summer season. There is no rainfall in the summer season. Rainfall occur only during monsoon. During non-monsoon, there is no rainfall. So how water comes to the river? This groundwater contributes some water to the stream. That's why the stream which has contribution throughout the year from this groundwater, that stream is called perennial stream. The streams which has contribution only for limited time, not throughout the year, it's called intermittent stream, especially during monsoon. Okay, during monsoon, if there is a small rainfall, and for that 1 month or for that 15 days or 1 week or 2 weeks, water will be contribution. There will be contribution from groundwater to the stream. That type of stream is called intermittent stream. Means that is not available throughout the year. Contribution will not be throughout the year. And the streams which have zero contribution from the groundwater, there's no contribution from the groundwater, that stream is called ephemeral stream. Okay, so there will be 3 streams: ephemeral, intermittent, and perennial. So here in India, 35 billion cubic meter of groundwater contributes to the stream. Otherwise, the stream will be dry during summer. Okay, 396 billion cubic meter water is available. Next, out of this, this 431 billion cubic meter, 246 billion cubic meter that recharge from rainfall. Okay, means contribution from rainfall during monsoon season. 67 billion cubic meter that contribution during monsoon season, but from other sources. Other sources like means used water. It can be used water, industrial water, or that we domestic use water that we are supplying, we are discharging. Okay, that water close to the groundwater. So there's 67 billion cubic meter during monsoon from other source. During non-monsoon, recharge from rainfall is 46 billion cubic meter, and 72 billion cubic meter. Okay, that recharge from other sources during non-monsoon season. Okay, so these are the contribution, different contribution during monsoon and non-monsoon season. And next comes to annual groundwater drought. Means whatever the we are not using all water. All groundwater we are not using. Okay, some portion of the water we are using. And how much we are using? 221 billion cubic meter that we are using for irrigation purpose, and this 22 billion cubic meter that we are using for domestic and industrial purpose. Okay, so this is the data of this central CGWB, Central Groundwater Board, in the year 2009. Okay, this is another another report, but it is a report of July 2014. Same CGWB report, July 2014. Annual groundwater available 433, where it is 431. Okay, 433. 245 billion cubic meter groundwater extracted annually for different use. For different use, we extract 245 billion cubic meter. A domestic 23, and here irrigation 222. Here in the in this report, 2009 report, it is how much? 243. 243. Here is 245 is extracted as per this 2014 report. We use for domestic 23 and for irrigation 222. Just little different from this 221, 222. Sorry, 221, 22. Here it is 222, 23. Just little different. And this is the state-wise report. How much water we draw for different use. Extraction total 34.88 we are extracting. Means Punjab people extract. Irrigation they use 34.17 billion cubic meter, 0.71 for domestic and industrial. Similarly for Haryana, okay, Karnataka, you can see. You see Punjab and the UP, they extract major water. Okay, Karnataka very less water. Okay, other states report is not given. West Bengal also extract 10.69. Okay. So this is the report of the state-wise how they withdraw water and how they use the water. Okay. So this is the available of groundwater as far as India is concerned. Next is availability of groundwater in India as per this August 9, 2009 report. Okay. This is the CGWB report. August 2009. This is the depth to water level, means meter below ground level. You can see the blue area represents less than 2 meter below groundwater level. Is available. Groundwater is available. 2 to 5 meter by this green line, green area. 2 to 5 meter below ground level. 5 to 10 meter by yellow area. That is 5 to 10 meter below ground level. Okay, this MBGL means meter below ground level. And this portion is hilly area. Okay, these portions are hilly areas. Okay. That's not considered. That means water cannot withdraw. And this 10 to 20 by pink area. This one in red area, it is 20 to 40 meter per meter below ground level, and this brown area is more than 40. Means here near the Rajasthan, you can see in the Rajasthan area, it is more than 40 meter. Okay, below ground level water is there. But here coastal area, you can see in the Odisha, Maharashtra, Madhya Pradesh, it is very less, 2 meter, less than 2 meter. It is available. And here the red lines, you can see the Punjab, Haryana, okay, some portion of the Rajasthan, it is 20 to 40. Okay, so here West Bengal, some area, West Bengal, Chhattisgarh, Bihar, okay, it is 2 to 5 meter, it is available. In the UP, you can see some portion UP, it is 5 to 10 meter below groundwater is there. Okay, so this is about the availability of groundwater in India as per this 2009 CGWB report. Next, another, this is the report of the SEM. Okay, SEM, this means this water meter of the depth of groundwater level. Okay, This is the ground depth of groundwater level, but the time is October to December 2018. Here it is 2009, here it is 2018. Okay, so here you can see Odisha is 2.65. It's depth of groundwater level. Depth of groundwater level, West Bengal 6.05, 4.93, Chhattisgarh. Okay, so this map shows actually depth of groundwater level and also shows how decline, groundwater decline. It's by different color. So, okay, so these are the state-wise depth of groundwater level, like in Andhra Pradesh 5 to 10, Puducherry 12.74, Tamil Nadu 7.46, Andaman Nicobar Island 1.1, Kerala 5.54, Karnataka 5 to 10, Goa 4.96. So state-wise, these are the depth of water, groundwater level. And the colors, there is 3 colors which represent the groundwater declines. That the white color represent that there is a groundwater decline, but less than 2 to 8, less than 2. This white means less than 2 centimeter per year, 2 centimeter per year. Okay, and this red area, okay, like in Gujarat, okay, Punjab, Haryana, this Jammu Kashmir portion, okay, it shows that more than 8 cm per year there is depletion. Per year 8 centimeter of ground level decreases. And this yellow portion, this portion like in Bihar, UP, some portion here, this portions, okay. So medium to high means 2 to 8 centimeter per year, the decline is there, groundwater decline. Okay, so we have covered this availability of groundwater both worldwide and in India, importance of groundwater, okay, and how groundwater formation occur. Okay, these things we discussed. Okay, thank you so much.